Okay, so at this point, we've introduced the exponentials, we introduced the inverse of exponentials, which were the logarithms, and we've found a way to derive certain properties of these functions. In particular, we have properties of exponentials. E to the a plus b is equal to e to the a times e to the b. E to the a minus b is equal to e to the a divided by e to the b. E to the a all raised to the r is equal to e to the r times a. Each of these three properties gives rise to these properties of the logarithm. And I'm just happening to use the natural log here just because that's my favorite base. Natural log of u times v is log of u plus log of v. Natural log of u divided by v is log of u minus log of v. And log of u raised to the r is r times log of u. Okay. So I'm going to basically do two examples and talk about how we're going to solve two equations. Okay. So the first equation is 8 times 3 to the x equals 7 times 5 to the 2x plus 1. Okay. And the question is what's the value of x? Okay. I cannot yet use this thing directly to get to this exponent. Okay. So the problem is for finding this x is I can't get to the exponent. Notice the bases are different, so I can't just use a nice base. So I'm just going to take the log of everything and hope that I can use some combination of these properties to make things work out. And I feel good about that because I have two multiplication here and a multiplication here. So I'm going to use this, then hope I can use this, and then I hope I can use algebra from there. So let's just take the natural log of both sides. So notice this does not look like log of something raised to a power because I'm multiplying in there. So I can't use this, but because I'm multiplying, I can use that property. So I can do that. Now, so that's just some number, that's just some number. Life is good. This looks like log of a number raised to a power, log of a number raised to a power. So now I can take that power and bring it out. And now I'm feeling very good about things because that's just a number, and this is now a linear equation that I need to solve. So I'm going to basically put all the constants on the right-hand side, all the x's on the other, factor, and then divide and go from there. So let's see. First thing I need to do is multiply that through. So I have that. And let's see, where are my x's? There's an x, there's an x, and let's see, there's a constant, oops, messed up. That should not be a plus, I should have brought that straight down. So that is equal, okay? So all the constants I'm going to put on the right-hand side, everything else goes on the left. So let's see, so that I've got my x, log 3 stays on the left. I'm going to subtract log of 8 from both sides. Log of 7 stays there. Then I'm going to subtract 2x log of 5. And this I'm going to keep there. Okay. Now I've got an x there and an x there, so I can factor that. So I get that. I'm just going to leave this alone. This is just some number, right? Number plus number plus number. And now I'm going to divide both sides by this big ugly thing. So then this is just going to be that. Okay. Now note, if I wanted to, I could use these properties on the right to bring all these things together and look at this in a different way. At this point, this is perfectly fine, there's nothing wrong with this, it's correct. And we're not asked to do anything in terms of expressing this in a different way, so just leave it as it is. That sleeping dog line. Okay. One last example. So in this example, we have log of 2x plus 1 plus 3 equals log of 5 minus x, okay? Now in the previous example, notice I did not go back and check to see if I could plug the numbers back into the original thing. And the reason was is that previous example we had exponentials, and the domain for exponentials is all real numbers. So there's just not a problem there. Here, I gotta be careful. The domain of the log, in this case the natural log, is positive numbers. So I'm going to plug back my numbers for x in and double check to see if it's going to satisfy that equation or if it's even possible. Okay. So let's see. All right, there's a number of ways to do this. One is I could subtract this from both sides, subtract 3 from both sides, then use this property to write it as a single log, and then take the exponential. And the reason I would want to do that is I've got things inside the log I need to get at. I can't just pull those out. I'm going to take a different way to do this. And what I'm going to do is I'm just going to use brute force, and I'm just going to take the exponential of everything and hope it works out. And I'm going to end up using these properties over here, working with exponentials, and then take the advantage of the exponential is the inverse of the log later. So I just take the exponential of both sides. I get that. Now I can't do anything with this because this is not, the log of 2x plus 1 plus 3 is not the inverse of the exponential. So I'm going to use this property to break those apart and separate them. Now I can say that this is e to the log of something, and I can use the fact that these are inverses. This is an inverse. E to the log of anything is just the something. Okay. Same thing here. Now this is going to be 2x plus 1 times e cubed. That's 5 minus x. And now I've got a linear equation. So this is just a constant. I'm going to multiply this through, get all the x's on the left, all the constants on the right, factor the x, and then solve just as before. So this is going to be 2x times e cubed plus 1 times e cubed is 5 minus x. So let's see, so there's an x, that's going to go on the left. Let's see, this is a constant, 1 times e cubed, 5, so all that's going to go on the right. So let's see, so I'm going to leave this over here on the left. I'm going to add x to both sides. I leave the 5 there, and I'm going to subtract e cubed from both sides. Now I can factor out the x. And then I can divide through by that number. Get that? Okay. If I plug this in the calculator, this comes out, can't read my own writing, is about minus 0.36 or 37. And if I take that number and plug it back into there, I'm just going to tell you that I did it, is that I found that 2x plus 1 is greater than 0, and 5 minus x is greater than 0, and that number, in this case, is going to work out okay. Right?